Here we're going to find an integral. It's a definite integral that represents the area between these two functions. It's good to have an idea of what these two functions look like. Y equals x squared is just an upward opening parabola, and y equals 6x plus 7 is a straight line that has a y-intercept of 7 and a slope of 6. Obviously not drawn to scale here, but what's important is that we realize that we have an upper function, that's this line, and a lower function, that's this curve. So we can find the area in between those curves using a definite integral. We'll find the limits in a second, but we're going to find this area by subtracting the upper function minus the lower function. The limits of integration on x are going to be the smallest and largest values of x in this region that we're integrating over. We find those limits by setting the two functions equal to each other. In my case, I have x squared equals 6x plus 7. That's a quadratic, so you should move everything to one side of the equation. And in this case, we can factor. If we couldn't factor this quadratic, what we would do is we'd have to use the quadratic formula to find the x values where these two curves intersect. But this is a much better problem when it factors. We get x equals 7 and x equals -1 as our two intersection points for these two graphs. Therefore, our lower limit on x is going to be -1, and our upper limit on x is going to be 7. That integral, of course, represents our area. Now let's move that integral down here and try to evaluate it. Reordering the terms just a little bit gives us this. We can then integrate, and we can evaluate that integral at the upper and lower limits to find the area. We could evaluate this by hand, but I'm just going to cheat and use Wolfram Alpha. This first piece is giving me 245 thirds. We subtract, and the second piece is giving me -11 thirds. Combine those two, and we get 256 thirds, which I don't think reduces, meaning we are finished with this problem.